Hello, welcome back. Today we are going to be taking a look at inverse operations, particularly that of the derivative and what we call the antiderivative. So before we begin into that, let's review what an inverse operation is. Suppose we have the equation x plus 3 equals 7, and we wanted to solve for x. Well, since we're adding, we know the inverse operation of addition is anti-addition. Ha 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 ha. Or what we call subtraction. So we would subtract 3 from both sides, and we would get x equals 4. The reason we're allowed to do this is because addition and subtraction are inverse operations, and inverse operations cancel. They undo each other. We can apply the same for derivatives. For example, let's say we are given the function y equals. If we were to take the derivative of y with respect to x, we would get dy dx equals 2x. Well, this is a derivative. I can solve for dy. So now what we want to do is we want to assume, let's say we're only given this derivative and we want to solve for the value of whatever y was equal to. So we have to isolate the y, just like we would have to isolate the x over here by subtracting 3. So to start, I am going to multiply both sides by dx. So I would get dy equals 2x dx. Now right away, this should look a little familiar to what we did last semester when we talked about Riemann sums and area under a curve. We see this function f of x times this dx right there. This has a very special name, though. This is what we call a differential equation. And we're going to talk more about this in just a few minutes, what it exactly is a differential equation. But because this is an equation, we can solve it. So we have to what's called undo this derivative. So we are going to undo the derivative by using its inverse operation. And to do this, we use what's called an antiderivative. And an antiderivative is exactly just that. It is the inverse of what we did with the derivative. And we have a very special symbol. And again, this symbol is going to look very familiar. We have this little symbol right here, which again we saw when we talked about area under a curve and Riemann sums. We had a special name for it, you might remember. This is called an integrand, or what we call it, which is what we call these integrals. So this symbol is what we call an integrand. And an integrand just basically says, well, what do I do to get the original function back? So if I integrate this side, this derivative, I'm just going to get y. Over here, well, the derivative was 2x. So when we're asking ourselves, well, what function had the derivative 2x? And of course, we already know that that's going to be x squared because that's how we got the derivative of 2x. But let's take a look at it mathematically, kind of what's going on here. If these are true inverse operations, the derivative and the antiderivative, if they are inverse operations, then we just have to undo that power rule. So our power rule was originally, we were going to bring down the 2 and then we subtract the 1. Well, we're going to do the opposite. So instead of subtracting 1, we would add 1 to the powers. And then instead of multiplying by that power, we would divide. It's the inverse. So I would divide by this 1 plus 1. And we would get y equals, this just becomes 2x squared over x squared. Whoops, over 2. That's embarrassing. Over 2. Which would equal y is just x squared, which is originally what we got. Now we are going to add something else to it, this constant, this plus c. Now this plus c does have a very important role for us because remember, when we take a derivative, we don't know what's beside us. We don't know what we're adding or subtracting originally because when we take the derivative of our constant, we got 0. So we don't know in the original function if there was something else there. For example, if I let y equal x squared plus 3, our derivative would be 2x. And even if it was just x squared plus 4, it would still just be 2x. So if we're only given the derivative, we don't really know what that original constant was because it just became 0. So we add this plus 3 just to call it some arbitrary constant. And that is what we call an antiderivative. So the antiderivative of 2x is just going to be x squared plus c. If you go to the next video, we're going to take a look at, we're going to explain this a little bit more, and we'll take a look at some more examples. We'll see you then. Bye-bye.